Thanks to PCBWAY for sponsoring this video. More information on them in a moment. In the last video, I showed you how you can make your own autonomous robot race car that races around a track that can be made out of RC track components or the cardboard that the box shipped the parts in. Now in this video, PCBWAY has sent me some special parts, and we're going to test them out on the racetrack. These include aluminum wheels, a special kind of sticky resin 3D print for wheels, and then after that we're going to add an Arduino Nano to see if we can make the car go even faster. So let's jump in and tune this race car. So here's the box that PCBWAY sent me. Let's open it up and see what kind of parts are inside. Now there's another video coming out after this, and it's going to show you how to make a neural network car. So some of these parts are for the next video, but I just want to see what some of the quality it looks like. Looks like it's been packaged really nice, and I have a ton of packages they sent me. I'm so excited to start building these robots. Oh, bonus, we got some stickers. Definitely going to be making a livery with those. But right now, let's check out the first set of wheels. It looks like it's been packaged up really nice here. And I'm gonna open it up and see what's inside. I think these ones have a lot of heft to them. I think these are my aluminum wheels I ordered. Yeah, these are amazing. So with these ones, we're gonna simulate some downforce, and there's actually some grip, especially on this plastic table. So I'm excited to see how they perform. And next, what we're going to do is look at our resin prints. These ones are made out of UTR Flex, which are being used right now to make robot wheels. So I'm really curious to see if this will be grippy enough to be on the track, or will the car drift around. But, oh, they're very, very flexible. That is awesome. I like the UTR Flex. Let's take a close look at the wheels. Here's the aluminum ones, and these ones are printed on an FDM printer. Wow, these are very high quality. You can't even see the layer lines, and they're super hefty. And then here's the UTR Flex. I'm so curious about these ones, and these ones came out so nice. And I can feel that they're very grippy, so I don't even think we'll need to add rubber bands or hot glue to it. And I wonder how that Flex is going to do when I put them on the motor. Let's start the test by standardizing a car. We're going to push the motors completely to the center, use the brake pad with the most friction, and then we're going to angle the sensors so they align with the chassis. So I want to keep everything as same as possible. And we'll use the same battery for all 3 runs. This is just a rechargeable 9V I use for all my robotics projects. Now you notice that the tires I'm using are slightly larger, and you'll find out why in the next video. But here's the PLA one with the hot glue for grip. Next we have the aluminum ones, which are super heavy and are going to simulate downforce, so I'm curious if that's going to speed it up or slow it down. And then we have our UTR Flex, and this one is super grippy and it's kind of flexible. I'm very curious to see that one. Up first are the PLA tires. I've set the clock to 0. Let's start it up, and as you can see, the track is an oval. Let's see how it does. Alright, we're on the go, and away it goes. Around the first corner, it's very smooth and stable, and then across the line for a time of 4.61. Not a bad time at all. Next are the aluminum tires. I've zeroed out the clock, just checking the track to make sure it's the same as possible. And let's kick the car on. Wow, these tires are very heavy. And away it goes. It is flying and keeping its momentum. I'll be curious to see if this beats the PLA time. And it does with a 4.59. That is really fast. Alright, now for the UTR Flex. This is just using the filament itself for grip. Will it slide? Will it wobble? Let's find out. And away it goes. Oh, it's very smooth, and it's very grippy. Like, it's not struggling to gather grip at all. And that one's not too bad, 4.83. Each wheel did really well. I'm so impressed that the aluminum ones were the fastest at 4.59. Thanks to PCBWAY for sponsoring this video. Let's take a look on how you can make your own parts on PCBWAY. So there's a bunch of options here. You can even make your own PCB if you wanted to make a robot just on a PCB board. But right now we're really interested in the 3D printing and CNC option. So we're going to go ahead and select that. And once you have that selected, we'll click this orange button here and make sure you select 3D printing. So first we're going to drag and drop our file in. So here's the file for the robot car kit. And you can see here's a 3D render of it. That looks really good. I'm very happy with that one. So we'll close the render here. And then I'm going to pick my material. They have a lot of options. We have resin, and we also have FDM. As you can see here, I'm looking through the different materials. You can see there's the grippy tires that we made in black that are flexible, but I want to print this chassis here in PLA. Oh, there's the aluminum one. So here's the PLA one. What I'm going to do is select the color. I'm going to select my favorite, lime green. We're going to select the infill. I'm going to keep it as light as possible because it's a race car. Here, if you use different filaments, you can change your finish level. And then down here, we're going to select what it's being used for. So I'm going to select the hobby one. I'm going to select other and call it robotics project. You can label it to whatever your project is. And then once that's done, we're going to scroll back up and we're going to generate the quote. And you just click this green button here and it'll begin generating a quote for you. It is really fast. Oh, let's make sure we accept the terms. And there you go. You just have to sign in and they'll email it to you. It only took like a couple minutes when I did my quote for this. They're really fast and they make quality parts. You can find the link to PCBWAY in the description below. Now let's add an Arduino to our robot car. The first step is to install the MBlock IDE, which you can find a link in the description below. So now we're going to have to find our microcontroller we want to use, and that's the Arduino Nano. Now you can see it's not showing up here, and that's because I have it under installed. I haven't installed it yet. So what we need to do is go to the device library and search for two different Arduino Nanos. Now we need to because when you purchase an Arduino Nano from Amazon or AliExpress, we don't know if it's the newer version or the old version. So how I test is I try to upload to one. If it doesn't work, I select the other. So what we're going to do now is find the pre-written code for this, which is on my old Instructables. This Instructable I wrote from the public library I used to work for, but we've adopted it here at the Tech Rockstar Academy. Once the download is complete, what we're going to do is close the MBlock IDE that we have open now. Now you do have to go in and close it manually, and if you hit save here, it's going to try to save it to the cloud. But because we installed those two microcontrollers, we can just close it without having to save. Now after that, we'll open up the download. And this will generate the code that I pre-wrote for this robot car. Now what you'll do is wait for the Arduino Nano to load, and you can select between the two, and it's both the same code. Now here's where you can edit the code. I have put notes to it so you can read it at a later time if you're going to go ahead and upgrade it. So here, the forward function, you have to put the same PWM values, so pulse width modulation, 0 is off, 255 is full speed. And the way these cars turn is like tank steering, so one wheel will go backwards and one will go forward, and that causes it to turn tighter and have a tighter driving line. So it should go faster than the standard analog car. Now I'm going to test, so I have the Arduino now hooked up. So I'm going to click that checkbox to show everything connected. It's usually the first COM port, and you can read more about that in the Instructable. So I'm going to try to upload it to the new Arduino Nano, and you can see here it's trying. And it takes a few minutes for it to try, and then it crashed, so that tells me it's the old one. So I'm going to go to the old one here, select it, and now I'm going to do the same thing. Now it's a good idea to go back and disconnect. It will automatically disconnect for you, but I just like doing that as a good habit. So go back, make sure it's COM10, we'll hit upload, and let's see what happens. So this looks like it's much more promising, and then there's the loading bar, and now the code's fully uploaded. So now let's add the Arduino Nano to the car and see how it does on the racetrack. So here's what you'll need to upgrade the car with. You'll need an Arduino Nano, you'll need a basic analog robot car with the breadboard attached, a Phillips head screwdriver to work with the motor driver, and some 10 centimeters male to female breadboard wire. So now we have to redo the power distribution, so I'm going to remove all the ground and all the power wires. I'm going to find the red wire that's coming from 5 volts. So untangle that, there's that one. And what we want to do is take that 5 volt wire, you can see there, and move it from 5 volts to the 12 volts. So that way we can power the Arduino Nano straight from the battery. So let's do that now. So now you can see it's coming straight from the 12 volt pin, and that'll be enough to power the Arduino Nano, and the Arduino Nano can be powered off a 9 volt battery, so it's only going to get 9 volts from there. So now we're going to attach the Arduino Nano. Now pay attention to the orientation. As you can see, the USB port goes to that side, and then it plugs right into the breadboard, and we make sure that there are 3 pins on the top there, 1, 2, 3, and 2 pins on the bottom, and that gives enough room to power everything. Just give the Arduino Nano a firm push into the breadboard and we're ready to power it. So we're going to take the wire coming from the 12 volt output on the motor driver and plugging that into the VIN pin on the Arduino Nano. Then we're going to take the ground wire coming from the motor driver and plug that into GND. And then we're going to line up all of the brown and black wires coming from the sensors along the GND rail. So it's vertical. And as long as they're aligned, they'll all be on the ground. And then we're going to take the 2 wires coming from the volts in on the sensors and plug that into the 5 volt pin on the Arduino to power the sensors. Once those are all in place, go ahead and power it on, make sure it works. And you'll see the car still driving, and that's because we have those wires still coming from the sensors. For our next step, we're going to remove those wires because we're going to add new wires to those sensors. So I'm just going to untwist it here and remove them. Once those wires are removed, we're going to go ahead and take a yellow and green one and attach those to the sensors. Now these are the 10 centimeter wires, and it'll just make the car look a lot cleaner. You can use longer ones or shorter ones if you wanted, but I find 10 centimeter to be the best. So we're going to take that yellow wire and we're going to put that into D12, which will then allow that sensor to send signals to the Arduino, which then will trigger the car to do its steering pattern. And then we're going to take the green one, and that one's going to go to D10. So you can see here, it's a little fiddly. Just take your time with it, and remember the motors, you can slide backwards and forwards. So let's find D10, and I'll plug that in. And of course, Instructables has a much better description and photos of this, so go ahead and take a look if you have any questions on where to plug that in. Alright, now that we have those installed and the sensors now are sending signals to the Arduino, what we're going to do is remove these enable pins from ENA and ENB. And if you ever want to make the car analog again, you just have to replace those ones. So go ahead and hold on to those. But in order to change the speed of the car, we're going to have to send signals from the Arduino Nano to those pins. And you can use a screwdriver to get them out. Now we're going to use the pins closest to the Arduino. You could use the back ones if you want, but I like using those ones that keeps it nice and neat. Now that the sensors are powered on and can send signals to the Arduino Nano, what we're going to do is connect the motor driver to the Arduino Nano. So we're going to take the yellow one, go into ENA and put that into D3. And D3 sends PWM signals, and the enable pins allow you to change the speed of the robot, so that's why they're there. Next, in1 is going to go to D2. This is controlling the direction of the motor. So in1 through 4 will do that. I'm going to find D2 and plug that in. Now if your breadboard's a little tight, I'd take in a spare wire and pre-punch the holes. Next we're going to take, I believe, a purple wire here. Oh, it's the white wire. And the white wire goes into N2, which then goes to D4. Now be gentle and take your time with this. It is a little fiddly, and sometimes the wires fall out, so you might have to go back and reattach them. So that's why the Instructable's there, just to help you. Now we're going to take the purple wire, and that's going to go to N4. And we're going to plug that into D8. And then finally we're going to take the gray wire and put that to ENB and to D9 on the Arduino Nano, which is another PWM pin, so that way we can change the speed of the robot. Now you can see here I knocked some out, so I have to go back, read the Instructable, and realign them. Now that the other 2 wires are back in place where they belong, I'm going to go ahead and finish ENB here and put that to D9. Now be gentle with these wires, they do tend to snap if you bend them too much, but not to worry, each pack of wires comes with extra, and those are listed in the Instructables. Alright, let's power it on, and you have to give it a second to turn on. I have that there so it doesn't just run away. Now you can see the motor's going the wrong direction, so we're going to note that, and we're going to go to the motor driver and just swap the motor wires around, and then it should start driving forward again. Now that's done, let's test it out. We're going to turn it on. There's a little hesitation, and now we can see the car is driving forward and turning in the right direction. Now let's give it a test on the racetrack. Alright, let's give this car a test with the UTR Flex tires. I really like those ones, they're super grippy. So we're going to go ahead and turn on the car. The clock is zeroed out, and let's see how it goes. And you can see it kind of struggles with going around the corners and even crashes there for a time of 5.25. So let's reprogram it and make it go faster. I programmed it to turn tighter and drive faster. So the clock is zeroed out. Let's see how it goes. So I'm going to turn on the car here. I like that little hesitation, it makes it easier to start. The way it goes, it does overshoot it, but it goes tighter to the corner, overshoots again, across the line for a 4:09. That's the fastest time of the day. It's pretty cool. In the next video, I'm going to show you how to make this neural network car. This car is trained versus programmed, and you'll learn all about that in the next video. But thank you for watching, and if you have any questions or comments, please leave them below. I'd love to hear from you. Until next time, thanks for watching.